Hello friends, this is Anant Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with problems on students recommendation. This is Harshit Pandey. He has asked me question 17 and 18 from Thermodynamics XE 2013 paper. Let us do that. The question goes like this. At a location where the atmospheric pressure is 98 kilopascal and the ambient temperature is 30 degrees centigrade, the humidity ratio is 0.01 kg per kg of dry air. A high pressure front moves over the location which changes only the atmospheric pressure to 1 or 2 kilopascal while the humidity ratio remains same. What is the partial pressure of water vapor in kilopascal to the first decimal place accuracy before the high pressure front moves in? What is the relative humidity of air under the influence of high pressure front to integral precision in percentage? Let us do that. First, let us do the first part. Okay. Now here one of the things we have to do is we have to see the whole question paper. In the initial part, when the question paper is shown, the initial data which is given, in that they have given the equation for partial pressure of water vapor at different temperatures, and that we have to see. So the data given at the initial of the question paper goes like this. It says partial pressure of water vapor log of P is equal to 18.558 minus 5190 divided by T, temperature in Kelvin. So if I use this, I will get partial pressure of water vapor at the temperature which is 30 degrees centigrade comes like this, 5190 divided by, we get temperature is 303.15, correct? 303.15 Kelvin, correct? So the answer for pressure, I will get it as 4.208 kilopascal. This is the first thing we have to do. Once we get that, then we can calculate the humidity ratio when it is fully saturated. The humidity ratio when it is fully saturated goes as 0.622. This is saturation pressure. 0.622 into PS, P saturation, divided by P total minus P saturation. This goes as 0.622 into 4.208 divided by total pressure goes as 98 kilopascal minus 4.208. This comes as equal to, when I solved it, I got the answer as 0.00279 kg per kg of dry air. This is the answer what I got. Now from this I can find out the humidity ratio. Humidity ratio is given as W by W at saturation. What is W which is given? W is given as 0.01. So 0.01 divided by W at saturation is 0.0279, and this comes out to be, for me it has come to be 0.3584, or I can say humidity ratio is 35.84%. This is the answer what I got. Fine. So once we get that, that is not enough. What is to be understood is this: humidity ratio phi is also equal to partial pressure of the water vapor divided by partial pressure at saturation. Okay, humidity ratio is known. Humidity ratio is 0.3584. That is equal to partial pressure of water vapor before that 98 kilopascal, before that high pressure front comes in, divided partial pressure at saturation is given as partial pressure of at saturation. We have got it as 4.208, correct? So 4.208. From this I can get partial pressure of vapor at that particular front is given as 0.3584 into 4.208, and I get the answer as 1.508 kilopascal. And this is the answer for the first question. So the first question answer is here, it is 1.508 kilopascal according to my calculations. Okay. Next, we will go for the second part. What is the relative humidity under the influence of high pressure front to the integer percentage? Now, one thing we have to understand is whether the temperature changes. Why? Because partial pressure, the saturation pressure, okay, depends on the temperature. When the pressure changes to 102 kilopascal, whether the temperature changes. Now here one thing we have to understand, whenever the pressure change happens, it can happen through isothermal process or adiabatic process. Now how do we decide? Here one of the things has been given. When a high pressure front moves over the surface, over the location which changes only the atmospheric pressure. So it has said only the atmospheric pressure changes. That means temperature does not change. So we can assume it as isothermal. When we assume it as isothermal, then the partial pressure of water vapor at saturation remains the same, 4.208. And now the humidity ratio also remains the same. What is changing is humidity ratio at saturation. Okay, because humidity ratio at saturation changes, my relative humidity also changes. So by the change in humidity ratio during saturation, which happens because of the change in pressure, okay, the atmospheric pressure, that has to be noted, and we have to see what is the relative humidity here. So let us see what is the humidity ratio at saturation at a higher pressure. So now this would come as W is equal to 0.622 into 4.208, which is the what you will say, the partial pressure, because the temperature has not changed, it will not change, it will remain the same. And here instead of in terms of atmospheric pressure, instead of 98 last time, this will be 102 into 4.208, and the answer what I get is 0.2676, okay, kg of water vapor. I'm sorry, it is 0.0, I'm very sorry, here there's a one order change, okay, 0.02676 kg per kg of dry air. Now after this, what happens is we have to calculate the humidity ratio, and the humidity ratio would be the one which is what you say, we can have here as the partial pressure, okay, or we can say W at the present humidity ratio divided by humidity ratio at saturation. What is the humidity ratio? Actual humidity ratio. Humidity ratio actual is 0.01 because it doesn't change, that's what is told, and saturation is 0.02676, and the answer what I am getting is 37.36. What I am getting is 37.36, or in percentage it is 37% is the answer. They have asked us to take the pressure front at the integer precision in percentage. So in percentage it is 37% is what we have to write. I hope you have understood this, students. If you have any further doubts, put it on the comments, and if you have any further suggestions for me to solve, kindly recommend it in the comments also. And best of luck for your exam, students. Thank you very much.